Hello everyone, welcome to my channel. This is an educational channel where we go over a lot of my heroes who have spent their whole life working on a theory of everything or an all-encompassing theory and put out something that was very worthwhile, but really didn't get the credit that they deserved, or any kind of recognition or any kind of money or anything. They just did it for the truth of everything, and a lot of times they made a mistake or two, but in general, the theory is very solid, and it's something that I feel that other people would benefit if they knew about it. So today is video number 191 on the reciprocal system of theory from Mr. Dewey B. Larson. And Mr. Larson died back in 1990, but for about 60 years before that, he worked out his reciprocal system of theory, which basically says that we live in a universe of motion. The universe is not made out of matter, it's not made out of energy, but it is made out of motion. Matter and energy are merely two different kinds of motion, of many kinds of motion. All of our basic mechanical and scientific quantities are kinds of motion. And motion is the relationship between space and time. Space and time don't really exist except together in motion. Motion is more or less a fraction that has time or space as the numerator and space or time as the denominator. Space and time both come in discrete units, meaning that there is a minimum unit of space and a minimum unit of time. And they're not continuous. They come in chunks. When they come together, they are come as units of motion. When you have one unit of space in one unit of time, you have the speed of light. So the speed of light is really the one, the midpoint, the reference point, or the natural reference system, even the ether, the origin, the null point of this universe. And there is a half of the universe that is moving slower than the speed of light, and a half of the universe that's moving faster than the speed of light. And that's where the coordinate and clock aspects of space and time also come in. Space and time are both coordinate, meaning that they both have 3 or more dimensions, x, y, z coordinates. And they also are scalar, meaning that they have an aspect that have motion, but in no particular direction. So you can envision this by using a balloon, putting a bunch of dots on the balloon. If you blow up the balloon, all the dots are moving away from each other. That is the progression of space, the flow of space. And normally we recognize that for time, time is flowing, time is always getting later and later and later. That is the flow of space, what Larson calls clock space, or clock time and clock space, and then coordinate time and coordinate space. So in the material sector, the sector of the universe that's moving slower than the speed of light, we have coordinate space and clock time. This is what we're used to. This is the universe that we live in, that we measure, make measurements from, make observations from. So that's 3 dimensions of time, 3 dimensions of space, and 1 dimension of time progressing. But in this half of the universe that's actually moving faster than the speed of light, the half of the universe that we really don't know too much about, and that Einstein kind of eliminated when he said that nothing moves faster than the speed of light. He was right about that, except that he didn't know anything about the half of the universe that moves faster than the speed of light. And so he just eliminated that. Generally, we see space, but we do not see time. Time is really invisible to us, and we only see it as it affects space. And so Einstein didn't really know anything about the half of the universe where there is coordinate time and clock space. So in this part of the universe, there's three-dimensional time, and that is moving through a scalar or clock space. Just the inverse of the material sector. So we can extrapolate what's going on in the material sector. We can figure out, we can observe that, and the inverse of that, when you reverse the roles of space and time, that is what's going on in the cosmic sector. A quick example of that would be basically like a magnetic field, a magnetic force. Force is time over space to the second power. So this is a cosmic aspect, and but we do not see a magnetic field because we don't see time. We only see space. So the magnetic, so like if you've seen like iron filings outside on a magnet that forms kind of a shape around the magnet, that is what you're seeing is you're seeing time, how time, we don't see time, but we see how time affects space. Okay, so what we're seeing is we're seeing the effect of time on space. And that is the iron filing. So the magnetic field doesn't really exist, but we can see, that's what we're able to see. Larson usually calls that equivalent space. So when something is actually moving in time, we see its inverse in space. And he calls that equivalent space. Now, we're looking at Larson's book that's called Nothing But Motion, which he put out in 1979. And it's generally on atomic physics. And we are in chapter 13 of that book, which is called, I think it's called Basic Mathematical Relations, something to that effect. And in this chapter, he's basically, so what Larson does is he goes over, he uses once he comes up with his, this chapter is called Physical Constants. And he goes over the theory itself, and then he takes the theory and he plugs it in and develops through the process of deduction. He develops an entire theoretical universe. Okay, and so this theoretical universe, he's developing it here in this chapter, having to do with the subatomic particles and the masses of the subatomic particles. In the previous episode, he derived the basic components of subatomic particles, and then compares them with the actual observations and measurements of scientists who have tried to measure the same thing. So he developed the values strictly from his theory of the primary mass, magnetic mass, gravitational mass, electric mass, in 3 dimensions and 2 dimensions, and the mass of normal charge and the electron charge. And then because for Larson, an atom is a combination of motions. In particular, an atom is two separate two-dimensional or magnetic rotations, and then an optional one-dimensional electric rotation. And then that whole thing can also be carrying a charge. And so there's all kinds of different basically atomic weight units that could be attached to the various particles. And we had just gone through how he derived the value of the electron and the positron. And so, one issue is that he develops it in all natural units, where, the speed of light is 1. And so he kind of goes from there. And he basically is saying that the fundamental constants that the physicists use are just kind of fudge factors to fudge over the fact that they don't know certain things, and so they plug in certain numbers. But when you use the reciprocal system, which has natural units, then you're dealing with you're dealing with natural units, and so the basic mass, the primary mass is 1.0000, and then he derives all these other units, and then they add together, and then so when he comes up with the electron and the positron, his numbers there are for the electron is 0.0005487, and then he says the observed value is 0.0005487. So we're getting all the way to the 8th decimal place before he's making there's any type of discrepancy between the two measurements. And now he's about to derive the massless neutron. So we're going to start reading Larson right from here. The massless neutron, the M 1/2 dash 1/2 dash 0, and again, those are the 3 rotations of an atom or subatom. The first is the primary magnetic two-dimensional rotation. The second is the secondary magnetic rotation, and the third is the electric rotation. And the M in front means it's from the material sector as opposed to the cosmic sector, which is a notation that he uses only for subatomic particles. So the massless neutron, which one of his followers actually identifies as the muon neutrino, but the massless neutron M 1/2 dash 1/2 dash 0 combination has no effective rotation in the third dimension, but no rotation from the natural standpoint is rotation at unit speed from the standpoint of a fixed reference system. This rotational combination therefore has an initial unit of electric rotation with a potential mass of 0.0005787, in addition to the mass of the two-dimensional basic rotation, which is 1.00639,205, making the total potential mass of this particle 1.00697,075. In this connection, it should be noted that the electron and positron also have rotation at unit speed, no rotation in terms of the natural system, in the two inactive dimensions. But these rotations involve no mass, as they are independent and are not rotating anything. The initial unit of rotation in the third dimension of the massless neutron, on the other hand, is a reverse rotation of the two-dimensional structure, and it therefore adds an electric mass unit. The neutrino M 1/2 dash 1/2 dash -1 has the same unit positive displacement in the magnetic dimensions as the massless neutron, but it has neither primary nor magnetic mass because these are functions of the net total displacement, and that quantity is 0 for the neutrino. But since the electric mass is independent of the basic rotation and has its own initial unit, the neutrino has the same potential mass as the uncharged electron or positron, which is 0.000578770. The potential mass of both the massless neutron and the neutrino is actualized, not being potential anymore, but actualized, when the rotations of these particles are joined to produce a three-dimensional rotation. The mass of the resulting particle is then 1.0075495. As indicated in Chapter 11, this particle is the proton. As it is observed, however, the proton is positively charged, and in this condition, the foregoing figure is increased by the mass of a unit charge, 0.000004494. The resulting mass of the theoretical charged proton is 1.007599439. The mass of the observed proton has been measured as 1.007600. So 7600 as opposed to 759439. Consolidation of two protons results in the formation of a double rotating system. And this double rotating system is what creates an actual atom as opposed to a subatom. As stated earlier, this substitutes one three-dimensional electric unit of mass for two of the two-dimensional units, reducing the combined mass by 0.0002895. The mass of the product, which is the deuterium atom, which is the mass 2 isotope of hydrogen, which is what the physicists would call the mass 2 hydrogen isotope, is the sum of two uncharged proton masses less this amount, or 2.014810. The corresponding observed value is 2.014735. So 14735 as opposed to 14810. Inasmuch as the proton already has a three-dimensional status, addition of another neutrino alters only the electric mass. The material neutrino adds the normal two-dimensional electric unit, 0.000578770, making the total for the product the mass 1 isotope of hydrogen, 1.0081285. The measured reported value is reported as 1.008142. So that's 812815 as opposed to 8142. The successive additions of neutrinos to the massless neutron that eventually produce the mass 1 isotope of hydrogen should be given special attention, as the considerations which will be discussed in Chapter 17 indicate that this addition process plays a very significant part in the overall cyclic mechanism of the universe. The following tabulation shows how the mass of the hydrogen isotope is built step by step. Okay, so this chart is saying step by step building process for the hydrogen isotope. First, we have the primary mass, 1.000000. Then we have the magnetic mass, which is 0.0063925, which is the inverse of the interregional ratio that he derived in this chapter earlier. That number 1408 over 9, which is 128 times 11 over 9. And he explains where those numbers are coming from earlier in this chapter, or in probably 2 episodes ago. Then we have the electric mass, 0.00057870. And then we have the massless neutron, which is M 1/2 dash 1/2 dash 0. So when you add those things together, you're basically adding all 3 of those earlier particles, the primary mass, the magnetic mass, and the electric mass, and you get 1.006977075, and that's potential mass. So then we have the neutrino. We've gone over this. I'm not sure that it's going to do any good to go over it again. But he basically has derived the values of the step-by-step building process for the hydrogen isotope. So it goes primary mass, magnetic mass, electric mass, and then you get the massless neutron, which is 1/2 1/2 0. Then you have the neutrino, which is 1/2 1/2 -1, and then you have the proton, which is 1 1 -1. And then you have the neutrino, which is M2-2 -1. And then you have the hydrogen isotope, 1, which is 3/2 3/2 -2. And that's where he gets that number 1.0081285. Neutrinos are plentiful. Oh, well, it looks like we are out of time. And so we will resume tomorrow discussing the neutrino and start from there. He'll be deriving some other values here in this chapter. You know, this is kind of stuff that you really have to study to really understand where he's deriving these numbers exactly. But he goes over it. You just have to, if you're interested, you will have to go over this very, very slowly. You know, listen to my videos over and over again, and listen to the language that he uses, and you'd be able to work it out. So good luck with that. Thanks for tuning in, and we'll see you tomorrow.